In this video, I would like to continue discussing the binomial expansion from our section 9.5 in our textbook. Okay, well, in the previous video, 9.5a, I talked a little bit about what the expansion looks like and how we get to this formula down here in the middle by continuing a pattern of expanding the binomial x plus y, taking it to the 0 and then to the 1, second, third, fourth, all the way to the nth power. Okay, so that's where I left off in the last video. Now let me talk a little bit about how to get these coefficients. Okay, so I mentioned that this coefficient here is given by this formula. And the way it reads is n choose r, n choose r, where n is the parentheses exponent, and I'm going to define r as the y exponent. All right. Now, I want you to notice something up here, that if you take a look at any particular term, for example, this middle one right here, if you look at the exponents on the x and y, and you combine them, the 3 plus 1, you get 4, which is equivalent to the parentheses, to the exponent on the parentheses. And that's the case for any of the terms in that particular row. So if we take a look at the next row, at the next term, we have x2, y2. If we combine them, we also get 4. And that happens once again in all the terms in that particular row. And that's the same, and the same thing's going to happen with any of the other binomial expansions. That's going to come into play a little bit later. Okay, so anyways, here's the formula, and let me do a couple of examples. Okay, so let's say that I want to know the coefficient of the term that has x cubed y1. All right, well, we will need to know what n is and what r is. And n is the, as I defined it up here, the parentheses exponent. But we don't have a parentheses here. We don't know what we're looking at. However, if we combined the exponents, 3 plus 1, we get the exponent on the parentheses. So 3 plus 1 is 4, and so that n is actually a 4. Okay, so n is 4. And the other thing that we need to to use this formula here is r. And r, the way I defined it again, is the y exponent. So r is 1. Okay, so we're going to plug them. So we're going to find 4 choose 1. So we plug them into this formula here, 4 factorial, and we plug in the r. And factorial, let me remind you guys that 4 factorial is 4 times 3 times 2 times all the way till you get to 1. And then 4 minus 1 factorial, that's just the same thing as 3 factorial, or 3 times 2 times 1. Now, the 3 factorial can cancel out with the 3, 2, 1 in the numerator, leaving you just the 4. 4 divided by 1 factorial, or 4 divided by 1, is 4. So the answer here is 4. Now remember the term here. The term is the one that has x cubed y1. Let me show you up here where that term is. x3y1 is right here. It's in the expansion that's to the 4th power, and it's 4. Okay, so in the same way we can get the 6 over here in the next term after that, or the 4, or any of the coefficients in any one of these terms. All right, well, let me continue. Let me do another example. Okay, so here we have a different term, x to the 10th, y to the 2nd, and what is this coefficient here? All right, well, once again, to use the formula, and choose r, we need n and r. N we can get by adding the 10 and the 2 here. So the combined exponent is 12. And r, again, is the y exponent, so y is equal to 2, or r is equal to 2. Okay, so we do 12, choose 2. And by the way, we can do this calculation in our calculators as well. But if you do it carefully, you shall see that the answer is 66. Okay, let me move on to another example here. All right, the next example has to do with problems where they ask you to find a particular term in the expansion. All right, so for example, right here, they say find the 7th term in the expansion, binomial expansion, x plus y to the 9th power. All right, well, we need to know what n is and what r is. And in this case, they tell us clearly what n is. N is 9. And so what is r? How did I get this to be 6? Well, remember, r is equal to the y exponent, and y starts with 0. So for the first term, y is 0. I mean, y is to the 0 power. The second term, y is to the 1 power. The third term is to the 2nd power. So the exponent on the y is always 1 behind the term. R is equal to the term that you're looking for minus 1. So for the 7th term, we actually want r is equal to 6. Once again, because y starts at 0. The exponent starts at 0 anyway. Okay? So once we have the n and the r, we have the formula here. The term is going to look like this. Okay, it's going to have n choose r, and then a combination of x and y. All right, well, the power on the y is going to be 6 because that's what r is, the y exponent, 6 and 6. The power on the x is going to be, it has to be 3 because 6 plus 3 needs to add up to 9, which is the parentheses exponent. Okay? And so once we do this calculation, the 9 choose 6, we'll have the complete answer. Okay? And let me work it out. Okay, and the answer is 84. When you do 9 choose 6, you get 84, and then you still have the x cubed and the y6. So that is that term, the 7th term of that expansion. Okay, here's another example. 2x minus 3y to the 6th power. Find the 4th term. All right, for right now, I'm going to pretend that instead of 2x is just x, instead of minus 3y is just y. All right, so I'm going to set it up the way I set up the example above. All right, so n is 6. That's given. Okay, and then it's looking for the 4th term, so it's going to be 4 minus 1. That's what r is. So it's 3. Okay, so here's my setup. You start by taking this 3 and putting it there. All right, and then the exponent on the x has to be 3 because 3 plus 3 has to add up to 6. All right, so it's 6 choose 3, x cubed, y cubed. Okay, this is the setup. Now, let's go back to the part that x is not really x. It's actually 2x. So instead of x, let's plug in 2x. Instead of y, let's plug in negative 3y, because that's actually what I have in the problem. Okay, so what I'm going to do is I'm going to simplify this expression here. So 6 choose 3 is 20. You can get that using the calculator again. And 2x cubed is 8x cubed. Remember, the exponent applies to the 2 as well. Okay, and then negative 3 cubed is negative 27 y cubed. I'm going to take the negative 27, the 8, and the 20, multiply them all out. I get minus 4,320 x to the third, y to the third. Okay, and that is the answer. Okay, and that is all. Yeah, and that is all for this particular problem because it's only asking for one term. Now, if in case they ask you to find the complete expansion, not only the fourth term, but the complete expansion, it's going to look something like this. It's going to be 6, choose 0, x and y. 6, choose 1, x and y. 6, choose 2, x and y. 6, choose 3, x and y. 6, choose 4, x and y, plus 6, choose 5, x and y. And then finally, 6, choose 6, x and y. And then the exponents are going to go like this. 0, 1, 2, 3, 4, 5, 6. For the y's, they increase by 1 every single time, whereas the x's start with the highest exponent of 6 and then drop by 1. Okay, so now we just did the third term, 1, 2, 3. We did this one right here. Or sorry, the fourth term, 1, 2, 3, 4. We did this one right here. Okay, as you can see, the exponents are 3 for x and 3 for y right there. We did that calculation. So if I ask you to find the complete expansion, then you're going to have to do these other calculations. 1, 2, 3, 4, 5, 6. 6 more calculations in order to have the complete expansion. And you just do it one at a time. And just remember that x is not really x and y is not really y. You would have to substitute the 2x and the negative 3y at the very end. But that would be the case where I do ask you for a complete expansion. Okay, and that'll be all.